Hello, in this video I'm going to explain fractional indices and how they interact with one another. In order to understand this, you do need to have the basic rules of indices pretty secure in your head. So you need to recall that when we multiply, we add the powers. When we divide, we subtract the powers. When there's a bracket involved, you multiply them, and that's a really important one actually. There are some tricky questions that you can be asked with that, so I might do another video on that in a bit. You need to understand that anything to the power of 0 is 1, and that if you have a negative power, you can turn that power positive if you put it underneath 1. My previous video does explain those last two a little bit more, so go and check those out if they look unfamiliar to you. So in order to understand fractional indices and how they interact with one another, it's important to consider some ideas. First of all, if we consider a to the power of 1, we could make that with a number of different powers of a multiplying. Remember that we add these powers, so if I have 3 and minus 2, I add them together, I get a to the power of 1. Likewise, I could have any value really. If I have a to the power of 78 and I multiply it by a to the minus 77, that's going to give me a power of 1 as well. They're not so useful, but something that is useful to consider is, what if I want the same power of a to be multiplied in order to add those powers and give me 1? Well, those two values would have to be a half, because a to the power of a half times by a to the power of a half, when we add those two powers, gives me the 1. But what can we say about, in this example, about a to the power of a half and a to the power of a half? Those two numbers that I've multiplied together to give a to the power of 1. What can we say about those? Well, we know that, to take an example of 9, we know that 9 to the power of 1 is just 9. It means we've got 9 multiplied by effectively 1. We've just got 9 on its own. So 9 to the power of 1, or just 9, is worth 9 to the half times by 9 to the power of a half, as we've just looked at. Because we add those two halves, we get the power of 1 and we get 9. Well, it's important to think then, what could 9 to the power of a half be worth? Well, a number that I multiply by itself to give me 9 is 3. And we also know that 3 is the square root of 9, which kind of gives us our first rule, that anything to the power of a half is the square root, because you're multiplying the same value by itself and then getting the value on its own. If you look at that example of the 9s, 9 to the half times 9 to the half just gives you regular 9. Therefore, the power of a half must mean square root. That's our first rule, so we need to put a fat box around it. But what about if I had a third then? Well, again, if I want to get a power of 1 and I can add the powers to get that, I could have a to the power of 1/3, add a to the power of another third, gives me 2/3, and then a to the power of a third gives me that a to the power of 1. So here we're looking at a value that multiplies by itself and then itself again and gives me that value. So if I take the example of 8, and I have chosen 8 because it's a specific type of number, 8 to the power of 1 could be written as 8 to the power of a third times 8 to the power of a third times 8 to the power of a third. So what do I know that multiplies by itself and itself again to give me an answer of 8? Well, that's 2. And 2 just happens to be the cube root of 8. So that helps us develop a second rule, that anything to the power of a third is actually the cube root of that value. Should put a big box around that as well, because it's another rule. Here's the kind of question that you could get asked in an exam though, and it's interesting for us to think that what on earth does 16 to the power of 3/2 mean, because that looks way more confusing. Well, actually, if you break it down, that's saying that we've got 6 to the power of a half, but we've got that 3 times. Recall that one of our key rules at the start was that if you've got a bracket, you multiply those powers. Well, 3 halves would just be written as 3/2 if I multiply that half by the 3. And that makes it really easy, because we've just learned that 16 to the power of a half means the square root of 16, which is 4. And then if I cube that, That's 4 cubed, which is 4 times 4 times 4, which is 64. And therefore, that scary thing at the start, 16 to the power of 3 over 2, is actually just 64. That's really important for helping us develop a more general rule so that we can evaluate any index or any fractional indice. So here are our key rules then. We've got a to the power of a half is the square root. We've got anything to the power of a third is the cube root. And in fact, if we want to take that a little bit further, anything to the power of 1 over n is just the nth root, because you appreciate that we can have square root, we can have cube root, or we could even go back a few more than that. We could have the 4th root, the 5th root, the 6th root, and so on. We've also just developed that if I have a slightly more complicated fraction, then the denominator tells me the root to take. So if I've got a to the power of m over n, I take the nth root and then I put it to the mth power. Right, if you're lucky enough to be in my class, I've set you this quiz on Show My Homework, so you can go and have a little go at that. If not, I've got some multiple choice questions for you to have a go at. If you do want any of the answers, I promise you that the correct answer is there as an option, so you should be able to chip away at it and maybe think about eliminating the other answers as to why they're incorrect too, because that's really good practice. But if you do need any of the final answers, then please just get in touch. So here's the first 3. And 2 more for you as well. That last one's really tricky. It's quite good fun, so keep having a play about with it. Let me know what you think. If you need any answers, get in touch. Thanks.